Welcome back. So we've talked about this point estimate and the margin of error giving us an actual interval around the point estimate, and we're using the values in this interval are our possible estimates of the unknown parameter, which is proportion of the population. What we still need to talk about is what do they mean when they say the level of confidence in this estimate is 95%. Well, that doesn't mean quite what a normal person would think it would mean. You know, I think a normal person, including myself, on hearing something like that would conclude that you know, there's a 95% probability that the true answer is in that confidence interval. You know, that there's a 95% probability that the actual population proportion is in that interval. And that is not what it means. And what it means is something a little bit more abstract and sort of technical. The level of confidence refers to the confidence in the estimation method, actually, not in the specific interval. So the 95% isn't saying anything about the actual interval. The 95% level of confidence means that if the same method was used 100 times, then 95 of the resulting intervals would contain the actual population proportion, would contain the true answer. So the 95% confidence level means if you use the same method, and also we haven't seen the method yet, so I know that word method doesn't make sense to you, but if you use the same sampling method and the same formula that I'm going to share with you in a minute, if you use that, then 95% of the times your interval would contain the actual population proportion. So like I said, that's kind of an abstract technical meaning of the word confidence. It's not the way probably most people would use the word confidence, but that's how it evolved in statistics. That said, you can think of a higher number as being a stronger conclusion, just like you would if you used this word the way an ordinary person would. So, you know, for an ordinary person, saying I'm 99% confident is better than saying I'm 95% confident. That's true here as well. Well, I need to give you the method, the formula for coming up with a confidence interval. There's some notation that we need to talk about first, though, because it shows up in the formula. So first of all, there's this notation Z sub A that we've seen before, and I think it was even flagged as an important notation, and then we didn't do anything with it. So it's very possible that you don't remember what that was. So let me just remind you, Z refers to the standard normal probability distribution. So this is our Z. Standard normal. And we've done a whole bunch of stuff with that. But what the Z sub alpha notation is referring to is if you have, let's say I've got area alpha under there, the Z value that has this area to the right of it is called Z sub alpha. So that's what Z sub alpha means. It's the number that has alpha area to the right of it under the standard normal distribution. And we're going to be using this idea of alpha and the Z alpha. In this context with the confidence interval, we're going to define alpha as the number 1 minus the confidence level as a percent. So this is all confidence level as a, that's actually supposed to be, say decimal. Okay, so confidence level as a decimal. So for example, if you're talking about a 90% confidence interval, what would the alpha be that goes along with that? Well, it's 1 minus confidence level as a decimal. 90% expressed as a decimal is 0.90. So for a 90% confidence interval, alpha would be 0.1 or 0.10. For a 95% confidence interval, Alpha would be 1 minus 0.95, so that would be 0.05. For a 99% confidence interval, alpha would be 1 minus 0.99, so 0.01. Thus, we can represent a confidence level as 1 minus alpha times 100%. So, for example, we've seen that for a 99% confidence, the alpha would be 0.01. Now, we can now take this is showing you how you can take the alpha and turn it back into the confidence level as a percent. So for this one, 1 minus alpha would be 1 minus 0.01, and then times that 100%. 1 minus 0.01 is 0.99 times 100%, and so you get the 99% back. Now, I know we just went in a circle there. Basically this formula is it's just relating the confidence level percent with this alpha, and the reason we want the alpha is it shows up in the formula that I'm going to give you in just a minute here. So circular, sort of circular here, but if you have the confidence level as a percent, how do you get alpha? You go 1 minus that confidence level as a decimal. If you have the alpha instead and you need the confidence level as a percent, that's going to be 1 minus alpha times 100%. So if you have alpha or the percent, you can get the other one. And that's probably a good stopping point. We'll come back in the next video and I'll give you those formulas with the alphas in them and an example of using that.